Imagine you have a task so enormous, so impossible, that even the fastest supercomputer on Earth would take 10 septillion years to finish it. That's 1 followed by 24 zeros. Think about it. If the universe itself began working on this problem at its creation, 13.8 billion years ago, we'd barely have scratched the surface. You'd need more time than the lifespan of our universe, the Sun, and every galaxy combined. But now, Google's new Willow quantum AI chip solves this in minutes. That's right, minutes. This is a section from the Google Quantum AI team presenting their chip. Stick around after this, where we explain what all of it means.
The systems behind our universe are quantum mechanical. They shift and change with the problems they're tasked to solve, exploring a vast array of options all at once. And like nature, quantum computing is responsive to the environments it works within, leading us to new breakthroughs for tomorrow's most challenging problems. Introducing our latest quantum computing chip, developed to learn and evolve like the natural world around us. Willow, from Google Quantum AI.
Hi, I'm Julian Kelly, Director of Hardware at Google Quantum AI. And today, on behalf of our amazing team, I'm proud to announce Willow. Willow is Google's newest and most powerful superconducting quantum computing chip, and the next step in our path towards building large-scale quantum computers and exploring their applications. It has been a dream to make our mission a reality, building quantum computers for otherwise unsolvable problems. We launched our first chip, Foxtail, in 2017, followed by Bristlecone in 2018 and Sycamore in 2019, which powered our milestone 1, the first quantum computer to surpass the best classical supercomputer on a computational task, random circuit sampling. Over the years with Sycamore, we have been able to squeeze a remarkable amount of performance from our hardware, including achieving a scalable logical qubit in our milestone 2. While we've ultimately been limited by quantum coherence times, the length of time qubits maintain their intended state. With Willow, we've made a huge step forward. We've increased quantum coherence times by a factor of 5, going from 20 microseconds in Sycamore to 100 microseconds in Willow. And we've accomplished this all without sacrificing any of the features that made our systems so successful. This advancement was enabled by our new dedicated superconducting quantum chip fabrication facility in Santa Barbara, one of only a few in the world. And we're seeing exciting developments coming from Willow, which has already surpassed Sycamore's breakthrough demonstrations. Our logical qubits now operate below the critical quantum error correction threshold, a long sought-after goal for the quantum computing field since the theory was discovered in the 90s. And we've achieved it for the first time with Willow. Errors are exponentially suppressed in our logical qubits, as error rates are halved each time we add physical qubits and scale from distance 3 to 5 to 7 surface codes. Additionally, our logical qubit lifetimes are now much longer than all of the lifetimes of the physical qubits that compose them. This means that even as we make our quantum chips larger and more complex by adding more qubits, we can use quantum error correction to actually improve their accuracy. We've pitted Willow against one of the world's most powerful supercomputers with the random circuit sampling benchmark. The results are pretty surprising. By our best estimates, a calculation that takes Willow under 5 minutes would take the fastest supercomputer 10 to the 25 years. That's a 1 with 25 zeros following it, or a timescale way longer than the age of the universe. This result highlights the exponentially growing gap between classical and quantum computation for certain applications. Let's talk about the hardware approach we've pioneered at Google Quantum AI that makes these things possible. Our tunable qubits and couplers enable super fast gates and operations to achieve low error rates, reconfigurability to optimize hardware in situ and run multiple applications, and high connectivity to efficiently express algorithms. We leverage this tunability to enable reproducible high performance across the device. Let me explain. A challenge in superconducting qubits is that not all of them are created equal. Some are outliers with uncharacteristically high errors. But here's where our tunable qubits really shine. We're able to fix these outlier qubits by reconfiguring them to perform in line with the rest of the device. And we can go one step further by having our researchers use tunability to continuously develop new calibration strategies that push errors down across all qubits with software.
This isn't just an upgrade in computing power. This is a paradigm shift, a quantum leap, literally, pushing the boundaries of what technology can achieve. We're entering a world where problems that once seemed impossible to solve are now routine. So what makes Willow so revolutionary? How does it work? And what does this mean for AI, humanity, and our future? Pay attention, because in this video, we're unpacking one of the most exciting breakthroughs of our time. Let's begin with where we are today: supercomputers. When you hear supercomputer, think of machines the size of warehouses, with thousands of processors humming away. Supercomputers are what scientists use to predict weather patterns, simulate nuclear reactions, or model the universe's origins. These machines are incredibly powerful, performing quadrillions of calculations every second. But even at this scale, they face a serious limitation. They process data linearly. One operation, one step, one calculation at a time, no matter how fast. Here's an analogy. Imagine you're searching for a specific book in a massive library. A supercomputer opens one book at a time, flipping through every page, no matter how fast it goes. For small problems, this works just fine. But when you're dealing with trillions of possibilities, this process becomes painfully slow, even for the best supercomputers. This is why certain problems, like accurately simulating molecular interactions, modeling quantum physics, or solving massive optimization puzzles, are beyond the reach of classical computers. It's not that they're slow, it's that some problems are so vast they require an entirely new way of computing. This is where quantum computers come in. To understand how Google's Willow chip is changing the game, let's break down quantum computing in a way anyone can understand. Classical computers, like the one you're watching this on, use bits to process information. A bit can be either 1 or 0, like an on-off switch. Every piece of software, video, and game you use is built from combinations of 1s and 0s. But quantum computers use qubits, and qubits are a game changer. A qubit isn't just 1 or 0. It can be both at the same time. Imagine flipping a coin. In the classical world, the coin is either heads or tails. But in the quantum world, it's like the coin is spinning and exists as both heads and tails simultaneously. What does this mean? It means quantum computers can process many possibilities at once, instead of one by one. Remember that library analogy? A quantum computer scans every book in the library at the same time. This is where things get even weirder. In quantum systems, qubits can become entangled, meaning they are linked together. Change the state of one qubit, and the other qubit responds instantly, even if they're light years apart. Einstein famously called entanglement spooky action at a distance. But for quantum computing, it's not spooky, it's revolutionary. These properties allow quantum computers to tackle problems exponentially faster than classical machines. But there's a catch. Qubits are delicate. Even a tiny bit of noise, heat, or interference can disrupt them. This is called quantum decoherence, and it's one of the biggest challenges in quantum computing. Enter Google's Willow chip, a quantum processor that's not only incredibly powerful, but also stable and reliable. Now that we know why quantum computers are so special, let's talk about Google's Willow chip, the star of the show. So, what makes Willow so groundbreaking? One of the biggest challenges in quantum computing is errors. Because qubits are so fragile, any disturbance can cause mistakes in calculations. Google has developed advanced quantum error correction techniques that make Willow's calculations far more accurate and reliable than ever before. Furthermore, Willow can maintain the quantum state of its qubits for much longer, which means it can solve bigger, more complex problems without losing precision. And before we go ahead, Willow isn't a one-off experiment. Google has built it to scale. They're developing systems that can handle increasing numbers of qubits, paving the way for even more powerful quantum processors in the future. The result? Willow can solve problems so enormous that even the best supercomputers would take 10 septillion years to complete, and it does this in minutes. Let's break that down. 10 septillion years is a billion trillion years. The universe is only 13.8 billion years old. If you put that in human terms, it's like compressing 10 billion lifetimes of work into a coffee break. Isn't that insane? That's not just fast, it's revolutionary. So, what can you actually do with a machine this powerful? The applications for Willow are almost endless. AI is built on data, mountains and mountains of it. Training large AI models takes weeks or months, even with today's supercomputers. Willow can reduce that time to hours or minutes, allowing AI to evolve faster than ever before. Imagine AI systems that can predict earthquakes, design personalized medicine, or create entire virtual worlds, all in real time. Not only that, but AI can make waves when it comes to drug development and healthcare. Developing a new drug involves simulating how molecules interact at an atomic level. A single molecule can have billions of possible configurations, and testing them all takes decades. Willow can simulate these interactions instantly, paving the way for faster cures for diseases like cancer, Alzheimer's, and even global pandemics. Additionally, AI can make changes in climate systems, which are incredibly complex, with countless variables. Willow can create models with unprecedented accuracy, helping scientists predict trends, optimize renewable energy, and develop solutions to combat climate change. From superconductors to next-gen batteries, Willow can also design materials that revolutionize how we store energy, power vehicles, and build technology. Imagine batteries that last 10x longer, or materials that conduct electricity without losing energy. In the world of finance, Willow's ability to analyze massive datasets at unprecedented speeds could revolutionize investment strategies. By processing trillions of data points in moments, it can identify market trends, optimize portfolio allocations, and even predict stock market behaviors with remarkable accuracy. Its computational power minimizes financial risks by running simulations and forecasting outcomes across volatile markets, offering insights far beyond the scope of classical systems. In logistics, Willow's problem-solving capabilities shine in optimizing global supply chains. From ensuring just-in-time delivery to managing inventory distribution across continents, the chip can calculate the most efficient routes, reducing delays and costs. For industries like aviation, Willow could reshape airline route optimization by considering real-time factors such as weather, fuel efficiency, and air traffic. Sure, quantum computers can crack traditional encryption systems, but they can also create unbreakable encryption. Google's advancements will play a key role in securing data in the quantum era. It's important to note that Google isn't alone in this race. Other tech giants like IBM, Microsoft, and Intel are all working on their own quantum systems. IBM, for instance, recently unveiled its own quantum processor. Microsoft is investing heavily in cloud-based quantum computing. But with Willow, Google has taken a clear lead. This isn't just a victory for Google, it's a victory for science, innovation, and humanity. Willow's success proves that quantum supremacy isn't just a pipe dream, it's happening right now. And this is just the beginning. So what does the future look like with quantum computing? In the next 10 to 20 years, we'll see AI systems that work hand in hand with humans to solve problems we can't even imagine today. There will be healthcare breakthroughs that save millions of lives. Energy solutions will power the world sustainably. And of course, we'll have quantum secure networks that make the internet unhackable. This isn't science fiction. With Willow, the future is unfolding right before our eyes. So what do you think? Is Google's Willow chip the most exciting tech breakthrough of our generation? Could it be the key to solving the world's biggest problems, from climate change to AI to healthcare? One thing's for sure, the future of computing isn't coming. It's already here. If you enjoyed this video, hit that like button, subscribe, and drop a comment below. What excites you most about quantum computing? Thanks for watching, and remember, the future is quantum and it's happening now.